All right, let's get right into it. Today, we are seriously going to level up our XPath game. We're going to master two incredibly powerful axes that will, I promise, change how you find elements in your automation scripts. We're talking about the Descendant and Descendant or Self axes.
You've been there, right? I know I have. You're staring at this super complex web page, and the element you need is just buried. It's like 5, 6, maybe 10 levels deep inside a whole mess of divs. It's so frustrating, and it usually leads to these really fragile tests that break the second a developer sneezes on the UI.
But what if I told you there's a much smarter, much more elegant way to handle this? In this explainer, we're going to see how you can grab literally any element you need, no matter how deep it's nested, using a couple of simple but really effective XPath tricks.
Okay, so before we get to the solution, let's just make sure we're all on the same page about the problem we're trying to solve. What makes locating these nested elements such a pain?
Well, modern web pages are kind of like those Russian nesting dolls. You've got elements inside of other elements, which are then inside even more elements. That simple button or input field you're trying to click might be a child of a div, which is a grandchild of another, and you get the picture. Trying to write a direct path like /div/div/div/span is just a total nightmare to maintain.
So, how do we cut right through all that complexity? Well, let's bring in our first tool for the job, the mighty Descendant axes.
The best way to think about the Descendant axis is like a family tree. So if you're the starting element, this axis goes out and finds all your children, all your grandchildren, and basically every single generation that comes after you. But, and this is the really crucial part, it selects them, but it does not select you. And the syntax for this, it's beautifully simple. You start by finding a stable parent element. That's our start node. Then you use a / followed by the magic keyword Descendant : That little double colon is key. It tells XPath, hey, we're using an axis here. And finally, you just tell it what target node you're looking for inside that whole family tree. Let's make this real with an actual example. What we're telling XPath right here is, okay, first things first, find me the div that has the class signup container. Got it? That's our starting point. Then, from that point on, find me every single div that exists anywhere inside it. Doesn't matter how deep. It's simple, it's powerful, and it's super direct.
Now, that Descendant axis is fantastic. It really is. But what if you actually need your search results to include the starting node? You know, the one you started from. Well, you're in luck. There's an axis for that too.
Meet Descendant or Self. Honestly, the name kind of says it all. If we go back to our family tree analogy, this one selects all your descendants. So your kids, your grandkids, the whole line, plus it selects you, the starting node. It gives you the complete package.
And just check out the syntax. We're using the exact same query as before. The only thing that's changed is we've swapped out Descendant for Descendant - or Self. It's such a tiny little modification, but it gives us a really important difference in the result.
So when you put them next to each other, it really just boils down to one single question. Do you want to include the starting node, the self, in your results? Descendant or Self includes it. Descendant does not. That is literally the only difference.
And this chart just illustrates that difference perfectly with some hard numbers. Using our example from the source, the Descendant query found 27 div elements. The Descendant or Self query, it found 28. So where did that extra one come from? You already know the answer. It's the starting div itself, the one with the class signup container.
Okay, you've totally got the core concepts down now. So let's level up. Knowing these axes is one thing, but using them like an absolute pro is where the real power is. I've got a couple of tips to make your selectors even stronger and more resilient. We're going to focus on two key strategies here. First, using wildcards to make your selectors more flexible, and second, adding attribute filters to make them way more precise. It's all about finding that perfect balance between the two. First up, the wildcard. You know, the little asterisk. Sometimes you just don't care if an element is a div or a span or a section. You just care that it has a specific unique ID, right? So by replacing the tag name with a star, you're basically telling XPath, hey, I don't care what the tag is, just find me any element with these properties. This makes your scripts so much more robust if a developer decides to change the HTML structure later on. Now on the flip side, sometimes Descendants can be a little too broad. It might return dozens of elements when you only want one. The solution? Add a filter. After you specify the Descendant tag, you can add a condition in these square brackets. Here, we're saying, find all the Descendant divs, sure, but I only want the one that has the class promo regular.
This lets you zero in on the exact element you need with, like, surgical precision.
So, there we have it. We've looked at the problem, we've covered the solutions, and we've even gone over some pro-level tips. Let's bring this all home.
At the end of the day, the real secret to mastering XPath isn't just about watching explainers like this one. As the source material really drives home, it's about getting your hands dirty. Seriously, open up the developer tools on your favorite website and just start playing around. Practice is what turns this knowledge into a real skill.
So I'm going to leave you with this thought. You now have two incredibly powerful tools in your toolkit for navigating even the craziest web pages. So think about that one element, that one test case that's always been a pain to automate. Now that you have this power, what complex automation challenges are you going to solve first?